This question is scheduled for discussing Clausius inequality, and the poll question which has been given to you, unfortunately 40% of the class are still confused about what exactly is the Carnot theorem. Okay, because without a clear understanding of what is the Carnot theorem, we won't be able to understand today's discussion. Hence, this question was given to you as a poll question. So let me close the poll and let me tell you the right answer. So the question was about the Carnot theorem, and the question was about the comparison of the irreversible engine with the reversible engine. Carnot theorem says that irreversible engine has less efficiency than the reversible engine. That is, the Carnot engine is more efficient, the irreversible engine is less efficient. So obviously, for the answer is irreversible engine having more efficiency than Carnot engine. This statement is false. So 55% of the students have got it right. It means that other 45% they are still confused about what is the Carnot theorem. So let me start the lecture with the discussion on Carnot theorem, and then we would be talking about what is Clausius inequality. Okay. So this is the agenda. Let me share the whiteboard. Okay, please tell me whether the whiteboard is seen, whether you see the whiteboard being loaded. Okay, thank you, Gargi. Okay, thank you, Dhiraj. Let me first wipe off this. Okay. Before I begin, let me write down what we are going to do today. Okay. The plan of today's lecture is I would be discussing what is known as Clausius inequality. Okay. So this is what I'm going to discuss today. Okay. So the plan is to discuss what is known as Clausius inequality, and I'm going to prove this. Okay. So what is this Clausius inequality? So first let me write down this. The Clausius inequality says that for any cycle, this inequality holds good. So for any cycle, this inequality holds good. This is what is known as the Clausius inequality. Okay, let me write down this. For any cycle, for any cycle means either for any cycle, meaning either the reversible cycle as well as the reversible cycle and the real cycle, that is the irreversible cycle. So for both the cycles, this inequality holds good. Okay, so Clausius inequality is cyclic integral of del q by t is always less than equal to 0, is always less than equal to 0. So the plan of today's lecture is to prove this inequality. Okay, we will be proving this inequality. So proof is what I am going to discuss in today's lecture. Okay, and to prove this I need to refer to what is called as the Carnot theorem. Okay, so let me rub this and write down. Okay, now it is clear to you that what is to be proved. It is to be proved that cyclic integral of del q by t is less than equal to 0, and this expression is known as Clausius inequality. Okay, so the plan of lecture is to prove this inequality, right? And my starting point is I would be starting this discussion, which I had already started by a poll question, by referring to the famous theorem, namely the Carnot theorem. Okay, so let me first, to prove this inequality, I will be referring to what is known as the Carnot theorem. So what is a Carnot theorem? So let me first write down what is a Carnot theorem. So Carnot theorem says that no heat engine can have an efficiency greater than the Carnot engine. Greater than the Carnot engine. So the Carnot theorem says that no heat engine can have an efficiency greater than the Carnot engine while they are operating between the same two temperature reservoirs. Okay, so source is one reservoir and sink is another reservoir. Okay, and making use of this fact, making use of this Carnot theorem, we would be proving the Clausius inequality. Okay, so I would be using the Carnot theorem to. So this is the agenda now, or working between the same two temperature reservoirs. Okay, so this is this one. Okay, this one is at highest efficiency. Okay, so now let us start with the proof. That is the proof for Clausius inequality. So let me rub this. Okay, so now we are going to discuss the proof of Clausius inequality. Proof for Clausius inequality. So it's very simple proof, so don't be afraid of this. So what we are going to do at the outset is we would be considering the reservoirs. Okay, as I said that let us say this is your source. Okay, source, and let us say that the source is at a temperature TH. Okay, and let us talk about the, let us say this is another reservoir, a sink, and let us say that sink is at a temperature TL. Sink is at a temperature TL. Okay, now let me consider, let me assume a Carnot engine operating between and a sink temperature TL. Okay, operating between source temperature TH and sink temperature TL means what? It means that this Carnot engine is accepting certain heat QH from the source, and this heat transfer is reversible heat transfer. This heat transfer is reversible heat transfer. Okay, and this Carnot engine is rejecting certain heat, let us say QL, and again this heat transfer is, let us say, a reversible heat transfer. Okay, by reversible heat transfer, what I mean to say is that when the heat is being accepted, okay, accepted by the working fluid of this Carnot engine, then this Carnot engine, let me draw it as like this is Carnot engine. Then this Carnot engine working fluid is accepting the heat at a temperature which is almost at TH. Okay, it is slightly less than TH, but this is almost at TH. Okay, so it would be slightly TH minus some DTH. Okay, and this DTH is almost zero. Okay, so we can as good as say that the working fluid is accepting the heat at a temperature TH. Okay, so this is called as a reversible heat transfer, heat addition. Similarly, when I'm saying that this Carnot engine is rejecting the heat reversibly, the meaning is this temperature the temperature at which the heat is being rejected. Okay, so this temperature is slightly, okay, slightly greater than TL. Okay, slightly greater, because without which there won't be any heat transfer. Okay, and this again, because it's a reversible heat transfer, it would tend to zero. It would tend to zero. Moreover, so this is called as a external reversibility. What we are talking about is a external reversibility. This Carnot engine is externally reversible in the sense that the delta T between this is almost zero, and delta T between this is almost zero. Okay, so this delta T is almost zero, and this delta T is also almost zero. Okay, this is the meaning of external reversibility. Now, this Carnot engine is also internally reversible, and because it is internally reversible, it is going to produce the maximum work. Okay, let us say it is going to produce the work equal to WC. Okay, so WC, or let me call it as, okay, WC, right? So WC is the work output of the Carnot engine. Okay, so this is one engine we had considered operating between a source temperature and sink temperature. Now let me consider another engine. Let me choose some other color for this. Okay, let me consider another engine which is now a irreversible engine. Okay, which is now an irreversible engine. This is an irreversible engine. Okay, so this engine is an engine working on some thermodynamic cycle, and this engine is an irreversible engine, or it is a real engine. Okay, and what it is doing is, this engine is accepting the heat from the source. Okay, so it's accepting the heat from the source, and let us say that it is accepting the same quantity of heat, QH. This engine is also accepting the heat, QH. Okay, QH. Okay, this is just to ensure that the input is same, right? And for comparison sake. And let us say that this heat transfer is also reversible. This is also a reversible heat transfer. Okay. Now, this engine is an irreversible engine, and let us say, because it is a different engine now, it is an engine, so the heat rejection would be something else. Heat rejection would be something else, and the work output also would be something else. The work output also would be something else. Okay, so let us call this as WI. Okay, WI. So this irreversible engine is also accepting the heat, QH, from the source. Irreversible engine. Okay. The Carnot theorem says that the efficiency of the Carnot engine is greater than efficiency of the irreversible engine, and output put upon input. So it means that the efficiency work upon QH would be greater than work I upon QH, right? And because this is same, the work output is greater than the output of the efficiency of Carnot is greater than efficiency of irreversible. Efficiency is work upon heat supplied. Heat supplied we are keeping it as same. So the work output of the Carnot engine is greater than the work output of the irreversible engine. Now, what is the work output of the Carnot engine? From the first law of thermodynamics, the work output of the Carnot engine is QH minus QL. That is the first law of thermodynamics. Okay. So this would be greater than what is the work output of the irreversible engine? It is QH minus QL dash. Okay, it is from the energy balance. You see that energy balance if you look at this. So WC is equal to QH heat supplied minus heat rejected. Similarly, WI would be heat supplied minus heat rejected. Okay, so from this what it means is that it means is QL is less than QL dash. Okay, it follows that QL is less than QL dash. Okay, so this is one. Let us call this as some equation one. Let us call this as some equation one. Okay, so from the Carnot theorem now we have got an insight that this heat rejected would be more obviously because the efficiency of the irreversible engine while operating between the same two temperature reservoirs is less as compared to the Carnot engine. So the heat rejected would be more. Okay. Now let us go to the cyclic integral of del Q by T. Okay. So what we want to prove is the inequality. Okay. So now I will be rubbing this. Let me rub this now, and let me calculate the cyclic integral. Let me calculate the cyclic integral of del Q by T for this engine, for the irreversible engine. So cyclic integral of del Q by T for the irreversible engine would be what? It would be QH upon TH minus QL dash upon TL dash. Oh, sorry, TL. Okay. We are assuming that this heat transfer is also reversible. Okay, so this engine also is externally reversible, but this engine is internally irreversible. Okay, so this is for convenience we are assuming because I wanted to use the same TL. Okay, otherwise I would have used a different TL and that would have made a bit complicated proof. Okay, so for simplicity I would say that the heat rejected is also reversible, heat supplied is also reversible. However, the engine is internally irreversible. Okay. So for this, QH by TH minus QL dash by TL would be the cyclic integral of del Q by T. So let us call this as equation 2. Okay. Now let me apply the Clausius theorem. Okay, not inequality. Clausius theorem to the Carnot engine, to the reversible engine. Now, what do we understand? What is the Clausius theorem for the reversible engine? Clausius theorem, not inequality, mind well. The Clausius theorem for the reversible engine is what? It is cyclic integral of del Q by T. Del Q by T is equal to 0. But what is cyclic integral of del Q by T? It is QH by TH minus QL by TL, and from, because this is a reversible cycle, which cycle? This Carnot engine. Okay, the first diagram. Okay, this is a reversible cycle. So according to Clausius theorem, cyclic integral of del Q by T for a reversible cycle happens to be 0. Okay, this is your equation 3. equation 3. Okay, so now look at this equations 1, 2 and 3 very carefully. Look at this equations 1, 2 and 3 very carefully. You will find that this term, this term is greater than this term is greater than QL. Okay, and when QL, then because for a reversible cycle, this becomes equal to 0, this becomes equal to 0, right? So if you are putting some other value, okay, which is greater than QL, look at it from a mathematical perspective. Okay, so if I am putting some value which is, then it becomes negative. So when I am putting, now you know this is the equation 3. You know this is equation 3. So this equation 3, if you compare it with equation 2, because this QL dash by TL, okay, it has to be negative, okay, has to be negative. But what is this? What is this? This is nothing but cyclic integral of del q by t for a irreversible cycle, okay. So let us call this as equation 4. Let us call this as equation 4. Okay. So what is equation 3 and what is equation 4? So equation 3 says that cyclic integral of del q by t, if it is a reversible cycle, that is equal to 0. That comes from the Clausius theorem. And what is equation 4? We have proved this, that cyclic integral of del q by t, if it happens to be an irreversible cycle, then the cyclic integral of del q by t will be less than 0. It means that that value would be negative value. Okay. Combining this two, that is combining the Clausius theorem with this equation 4, we can write a famous inequality, that is cyclic integral of del q by t, is less than equal to 0 for any cycle, okay. So this is known as Clausius inequality, okay. This is known as the Clausius inequality. So this inequality is valid for the reversible cycle as well as irreversible cycle. When the cycle is reversible, then the equality holds good. When the cycle is irreversible, then the less than 0 sign holds good. Then the less than 0 sign holds good. Okay, that means if it is the reversible cycle, then cyclic integral of del q by t will be equal to 0. And if it is an irreversible cycle, if it is a real cycle, then the cyclic integral of del q by t will be negative. This is now a very important tool. You try to understand that this is a very important tool to decide whether the cycle is reversible or irreversible. Okay, so the Clausius inequality helps you decide whether the cycle is reversible or irreversible. If you do the calculation for a given engine, and if you find that cyclic integral of del q by t becomes zero, then you can say that the engine is a reversible engine. If you find that the value comes negative, then you should say that the engine is an irreversible engine. One more thing, and this is a very beautiful thing, it is, if it is more negative, it will be more irreversible. So is the significance of Clausius inequality. The significance of Clausius inequality is that it is now bringing up the quantitative parameter of So you need to vote fast. Only 34% of the students have voted. So the question is about the Clausius theorem. And Clausius theorem, as I had said, it is cyclic integral of del q by t is equal to 0. Okay, so we need not confuse Clausius theorem with Clausius inequality. Should not confuse the Clausius theorem with Clausius inequality. Clausius theorem is cyclic integral of del q by t for a reversible. Some students are writing integral of del q by t 0. That is, you need to vote fast. Only 40% of the students have voted. It means that others are let me close this poll and let me show you the result. Okay, the question is about Clausius theorem. Okay, and it is whether the theorem is applicable to the cycle or whether it is applicable to a process. So as I had already told you that it is applicable to a cycle and not to a process, thermodynamic cycle. Okay, and the second part of the question is whether it is applicable to a reversible cycle or whether it is applicable to an irreversible cycle. So obviously, when you are saying that cyclic integral of del q by t is equal to 0 for a reversible cycle, that is what is the Clausius theorem. It means that it is applicable to a reversible cycle and not to the irreversible cycle. Okay, so the students who are writing it as irreversible cycle, they either are not attentive or they are having some bandwidth problem. So whatever. So let me close this and share the results. So the answer is about 50% of the students have answered it correctly. Okay, about 50% of the students have answered it correctly. The correct answer is it is applicable to a reversible cycle. Okay. Now let us see whether you have followed my discussion in the today's lecture. This is to test whether you are really understood this question. Okay, let me close the poll and show you the results. About 80% of the students have got it right, and I had explained you why it is so. So what I have done is that I have made Atharva Ugule, Sairaj, and Shivam Salunke the panelist. Okay, and I want you, Atharva Ugule, to explain this again. Whatever I had explained you regarding the heat rejection, why the heat rejection is more in case of irreversible engine. So I want Atharva that you should explain this again. Atharva Ugule, I made you panelists. Atharva, Sairaj, and Shubham Salunke. Atharva, speak up. I want you to explain this, Atharva, Sairaj, and Shubham.
Hello, sir.
Okay, Sairaj.
I am Sairaj.
Sairaj.
In irreversible
Okay.
process engine, the work output is more, so heat rejection is more. In Carnot cycle,
No.
heat
In
work
irreversible engine, the work
work
output is less.
work output is less, so the heat rejection is more.
Yeah, that is correct. Atharva Ugule. अथर्व उगले झोपलाय का पिक्चर बघतोय का अथर्व शुभम साळुंके शुभम साळुंके See, based on your responses, we will be evaluating you. Okay, we don't want that you are sitting there passively. And now Darshan Tamboli. Okay, I am making you panelist Darshan. Darshan Tamboli, speak up. Darshan Tamboli.
Hello, sir.
Darshan.
Yes, sir.
Hello, Darshan. You
Hello.
explain me why the heat rejection is in case of irreversible engine.
1 minute, sir.
Yeah. Darshan. दुर्ग ओंकार फेकळे भावेश दर्शन I want you to answer. Okay, ओंकार भावेश दर्शन शुभम साळुंके.
Hello.
Hello.
Sir, for irreversible heat engine, the heat the work output is less since the heat rejection is more.
Heat supplied is same, so the heat rejection would be more. Right. Very good.
Yes.
Gaurav Nagare. हंसराज गावित. हंसराज गावित आलाय का? हंसराज गावित. Gaurav Nagare. Gaurav Nagare. Which engine has a more efficiency, Carnot engine or irreversible engine? Gaurav Nagare. Gaurav Nagare is seen offline. Bhavesh Toke. Shubham Salunke. Hansraj Gavit. हंसराज गावित आवाज येतोय का हंसराज? Okay, all right. I guess that this discussion on Clausius inequality is clear to you. Okay, henceforth, I would be putting you on the panelist list, and I will be specially choosing two categories of students: one very sincere students and one extremely insincere students. Insincere in the sense of attendance. Okay, so I will be choosing two categories of students to respond to my questions. Okay, so when you come for the lectures, and I will be noting down that those who are not answering and those who prefer to remain silent when I make them panelists, and if they are not answering the questions, I will be considering that their performance is not up to the mark. Okay, so we would be having more active sort of learning henceforth from the next week. So I want you to revise the concepts which are being taught to you. I want you to listen to the videos which are shared by Professor Murukkar and come prepared for the lectures. Okay, don't come simply to mark or show your attendance, because if we want to give you internal marks, then we would be requiring to test you occasionally, and that one method of testing your intelligence is by making you answer the questions. Okay, so please, whenever the lecture is scheduled and whenever the videos are shared, I want you to listen to the videos and come prepared. Okay, there are some students, for example, today I had selected a few students like Hansraj Gavit, who is having a poor attendance. Okay, in my or Atharva Ugle also. I am filling the attendance in ERP. Others are also filling the attendance in ERP, and we are now able to personally know you. Okay, not by from your faces, but from your attendance record. Okay, we are now able to categorize the students into two or three categories: the students who are very regular in their lectures, and the students who are extremely irregular in their lectures. Okay, so we have started categorizing the students. So I want you all to be in the regular attending category, and not only attending category, but I also want you to be in the understanding category. Okay, if you are simply attending it without understanding, it is meaningless. We are available for your doubts. Okay, whatever doubts you have, you can share those doubts using the WhatsApp option. Okay, thank you for attending this class. Okay, today we had a discussion on Clausius inequality proof. I am ending this webinar. Have a good day. Thank you.